Close your eyes and try to touch the exact tip of your nose. You can probably do it perfectly on the first try. That simple, everyday motion actually requires a hidden spatial awareness system, mapping your exact bodily dimensions in real time. We are taught in grade school that humans rely entirely on 5 basic senses to navigate the world. It is a biological doctrine dating all the way back to the Greek philosopher Aristotle in 350 BCE. We know our eyes, ears, and skin process the external environment. But if those senses strictly handle the outside world, what biological hardware is tracking the massive amounts of data inside our own bodies? Modern neuroscience shows that focusing only on those 5 traditional inputs leaves us completely blind to a massive network of internal sensors keeping us alive. This 3D wireframe illustrates proprioception, your internal navigation system allowing you to walk downstairs without looking at your feet. Inside your muscles, microscopic sensors track length and tension, constantly streaming structural data straight up your spinal cord into your brain. We usually only realize how critical this data stream is when it completely stops. In 1971, a 19-year-old named Ian Waterman contracted a rare autoimmune reaction after the flu that permanently severed his proprioceptive nerves from the neck down. His physical muscles remained perfectly healthy, but his brain no longer received any coordinates from his limbs. If the lights went out, his body would instantly collapse to the floor, having lost all ability to feel where his limbs were in space. He had to relearn to walk by carefully watching his feet, using his eyes as a manual replacement for his missing internal GPS. Proprioception provides the required structural framework for every movement you make. This diagram maps out a second hidden sense, interoception. While proprioception manages physical structure, this network tracks your vital organs, pulling status reports from your heart, lungs, stomach, and bladder. It acts as an internal thermostat, monitoring these metrics to maintain homeostasis, the exact biological balance your body needs to survive. Because this physiological data is massive and constant, the processing happens almost entirely in the background. You usually notice it only when a signal breaks through to your conscious mind, like a sudden drop in your stomach or a racing pulse. Scientists are discovering that these raw internal signals serve as the baseline for our emotional states. When the physical data stream stutters or fails, it triggers intense psychological reactions. This flowchart demonstrates the mechanics of a common anxiety loop. A person might experience a completely normal, slight increase in heart rate. But if their interoceptive system misinterprets that data, the brain inflates a minor physiological blip into a massive, life-threatening emergency. Researchers at UCLA have found similar wiring errors in patients with anorexia nervosa. Their nervous systems actively mistranslate signals coming from the gut, causing patients to eventually stop registering the physical sensation of hunger entirely. Clinical studies also revealed distinct variations in how men and women process these internal signals. Researchers suspect these biological processing differences, particularly during hormonal changes, play a significant role in why anxiety rates differ between the sexes. Many debilitating psychiatric conditions stem directly from this broken feedback loop. The body generates correct physical data, but a translation error in the interoceptive network feeds the brain corrupted emotional software. The medical community is finally treating this internal infrastructure with the urgency it requires. The National Institutes of Health recently launched a $14.2 million 5-year research project dedicated strictly to decoding these hidden senses. The initiative is being led by Dr. Artem Patapoutian, a neuroscientist who won the 2021 Nobel Prize for discovering the exact cellular sensors that allow us to feel physical touch and temperature. His team is focusing heavily on the piezo-2 gene, which regulates these hidden networks. Their goal is to build the first complete 3D neurological atlas, a comprehensive map showing exactly how every organ wires directly into the brain. By identifying the exact neural pathways where interoception and proprioception break down, researchers hope to develop highly targeted treatments for chronic pain, autoimmune diseases, and severe psychiatric disorders. You do not have to wait for a medical breakthrough to improve your own internal hardware. These hidden neural pathways are highly plastic, meaning they can be actively trained and strengthened, just like the muscles they monitor. You can train your proprioceptive network simply by standing on one leg for 30 seconds while brushing your teeth, or by carefully performing slow, deliberate stretches in a safe room with your eyes closed. This forces your brain to rely entirely on the internal data stream instead of visual cues. To improve your interoception, researchers recommend dedicated mindfulness meditation. By sitting quietly and actively focusing your attention solely on your physical heartbeat or the exact expansion of your lungs, you calibrate your brain's ability to read those internal signals accurately, which directly reduces anxiety. We spend almost our entire lives reacting to the sights, sounds, and physical impacts of the outside world. But long-term human health relies entirely on the quiet, continuous data flowing beneath the surface.